During the night, as we get at the dark blanket of the sky, we see twinkling stars. These stars might be emitting light that traveled thousands of years to reach us. Or the stars we observed in space might have moved or disappeared from their original position long ago. Among these stars, some are much larger and brighter than our sun, while others are relatively small. In this video, we will explore the mysterious world of these countless twinkling stars based on experimental reasoning and principle of great astronomers. We will learn about scientists determine the distance of stars from our Earth. So let's start the video. Our Sun is also one of the shimmering stars present in space. The only difference is that the Sun is closest to us, making it appear significantly larger and more dazzling. However, these twinkling stars are so distant that either we can't see many stars, or they appear as flickering peaks in the sky resembling fireflies. What exactly is a star? A star is a colossal celestial body of gas, an astronomical entity that shines through radiation derived from its internal energy resources. The energy resources are vast spheres of hydrogen gas, which undergo nuclear fusion reactions, transforming hydrogen into helium and releasing energy through the process of nuclear fusion. In summary, stars are like giant cosmic spheres of gas that emit light through their internal energy processes, with hydrogen gas serving as an infinite reservoir. This hydrogen undergoes nuclear fusion reactions, converting into helium and producing energy. In the quest of understanding the universe, astronomers use various tools and techniques to measure the distance of these stars from Earth. By applying principles of astrophysics, they unravel the mysteries of these celestial bodies twinkling in the vast expanse of space. In this video, we will delve into the fascinating world of stars and explore how scientists unveil the secrets of the distant luminous objects in the night sky. Stay tuned for the intriguing journey through the cosmos. About 200 years ago, we have limited knowledge about the distance of stars from us or their nature. Then in 1938, German astronomer Friedrich Wilhelm Wessel for the first time accurately determined the distance between the Sun and another stars using trigonometric parallax. Speaking of Wessel parallax method, we may have encountered it in our high school or intermediate level math classes. Through this method, we can easily determine the distance of an object. To understand this, let's look at the diagram. We choose 2 points T1 and T2 to present the two objects. The distance between these two objects is known to us, which we consider as the base in the diagram. By drawing a line perpendicular to this base, we can determine the angle between the 2 points, and using the trigonometric formula, we can easily calculate the distance between these two objects. Now, let's get into the practical aspect how we calculate the distance between the Sun and stars. As we saw in the diagram, the larger the distance or base between the 2 points, the larger the theta angle will be. However, we can't measure a distance between Earth and star directly, because if we move from one corner to other in the Earth, the base length will not be significant enough to determine the angle near any star. Wessel addressed this challenge by considering Earth as a spacecraft and conducting experiments to measure the distance between Earth and a star. Vessel first test involved treating Earth as a spacecraft and assuming the orbit of diameter as the base. The second test conducted 6 months later when Earth reached the opposite side of the Sun, aimed to compare the relative positions of the stars. Unfortunately, in this first attempt, Vessel chose a star that was so far away that it was nearly equivalent to the Earth's orbit diameter, leading to disappointment. Later, Bessel conducted another experiment choosing a star that appeared quite bright and relatively close to the Earth compared to other stars. The star's name is 61 Cygni, located in the Cygnus constellation. Vessel successfully measured the distance of 61 Cygni from Earth, determining it to be 10.4 light years, which was close to the actual distance of 11.4 light years. Speaking specifically about Cygni, it is binary star system revolving around each other in period of 659 years. These stars belong to the K-type and are about 30% smaller and less luminous than the Sun. They can be observed with the naked eyes in rural area during a night time. After some time, Frederick George Wilhelm Struve and Thomas Henderson using the trigonometric parallax method to measure the distance of Alpha Centauri and Vega stars. Alpha Centauri, being the closest star to Earth, has a distance of 4.246 light years. As we know, light travels about 3 lakh kilometers in a second. Thus, it takes approximately 8 minutes and 22 seconds for light from the Earth to reach on the Earth. In the case of Alpha Centauri, the light takes about 4.246 years to travel from the star to Earth. An interesting point to note is that the star we see today emitted the light roughly 4.246 years ago, or if the star suddenly disappears, we would only receive this news 4.246 years later. Betelgeuse star, approximately 300 light years away from our Sun, there exists a star named Betelgeuse. This star is about 700 times larger and 3,600 times more luminous than our Sun. It is the 10th brightest star visible to the naked eyes in the night sky and is the second brightest in the Orion constellation. Following Rigel, scientists estimate that Betelgeuse is over 10 million years old. And due to its massive size, it rapidly developed. It is speculated that within 100,000 years, Betelgeuse will conclude its development with a supernova explosion, shining as brightly as the moon for 3 months when observed from Earth. Using the Hubble Space Telescope, study have saw that Betelgeuse began to lose its brightness from October 2019, and by March, its luminosity had decreased by about 3 times. However, in April 2023, the star regained its previous brightness. Research indicates that the star expelled a significant amount of material from its surface in the form of dust. Instead of staying close to the star, this dust spread out in a cloud millions of kilometers around, causing the decrease in its brightness. Subsequently, the dust cooled and condensed, and Betelgeuse returned its former brightness. Betelgeuse is so large compared to our Sun that if it were placed in the Sun's position in our solar system, its surface would extend beyond the orbit of Jupiter. Rigel star, located 860 light years away from Earth, outshining the Sun in luminosity ranging from 61,500 to 3,63,000 times brighter. It is nearly 24 times larger than our Sun. Rigel is the brightest star in the Orion constellation, appearing as the 7th brightest star in the night sky from Earth. The surface temperature of Rigel is approximately 12,100 Kelvin, estimated to be 7 to 9 million years old. Rigel emits over 10 million times more energy than the Sun, having exhausted its hydrogen fuel. Rigel's exoplanetary brightness is attributed to its rapid development towards become a supernova. Scientists anticipated that Rigel will end its life as a type II supernova, eventually transforming into a neutron star or black hole. Dhruva star or Polaris. Dhruva, also known as a pole star, is situated about 434 light-years away from the Earth. Although it appears as a single star, it is in reality a group of multiple stars, with Dhruva A being a primary star. Classified as an F7 yellow supergiant, Dhruva is a 45th brightest star visible from Earth. Dhruva is around 2,200 times more luminous and roughly 30 times larger than the Sun, with an estimated surface temperature of 7,200 Kelvin. Sirius star. Found in Sirius constellation, Sirius is the brightest star visible in the night sky from Earth. Though observed as a single star with a naked eyes, it is a binary star system. Sirius is located 8.6 light-years away from Earth, shining 24 times more brightly and being approximately 2 times more massive than the Sun. Due to its proximity and size, Sirius appears as the most luminous star in the sky and is expected to remain the brightest for the next 2 lakh years. Scientists predict that Sirius is gradually appearing our solar system and will continue to increase the brightness over the next 60,000 years, with an estimated lifespan of 120 to 300 million years. Sirius is anticipated to exhaust its hydrogen, transforming into the white dwarf and later into a massive red giant. The Sun. Our Sun is indispensable for life on Earth. It has a mass of approximately 2 into 10 to power 30 kg, about 330,000 times more massive than the Earth. The Sun is located around 33 million miles or 150 million kilometers away from Earth, with a diameter about 13,91,400 kilometers. The Sun orbit is galactic center of our Milky Way galaxy at a distance of approximately 26,660 light-years, taking about 225 million years to complete one revolution. Its orbital speed around the galactic center is approximately 220 km per second. The Sun, in its current position in our galaxy, has witnessed significant change on Earth, including the era of dinosaurs. There is a dedicated video on the extinction of dinosaurs and its relation to the Sun's position, which you might find interesting. About 99.86% of our total mass in our solar system is concentrated in the Sun. In the Sun's position consists of 73% hydrogen, 25% helium, and the remaining percentage including oxygen, carbon, neon, and iron. Its actual color is white, and through nuclear fusion reaction, the Sun converts approximately 600 million tons of hydrogen into helium every second, releasing about 4 million tons of energy. This energy travels from the Sun's core to its surface, a journey that takes about 1 lakh years. Scientists predict that the Sun's energy will deplete in the next 5 billion years. After that, it will transforming into a red giant, followed by a white dwarf and eventually a massive black dwarf, black celestial body. In the vast universe, there is the countless stars. In the vast universe, There are countless stars, and counting them all would take millions of years. During the night with the naked eyes, we can see around 2000 stars. However, with telescopes like the 100-inch telescope at Mount Wilson Observatory in California, around 5 crore stars can be observed, and even more with larger telescopes. Our Milky Way galaxy alone contains approximately 100 billion stars, including our Sun. The galaxy spans about 1 lakh light years in diameter, with the spiral shape. Furthermore, the universe is filled with billions of galaxies, and Andromeda galaxy is the closest to our Milky Way galaxy. It is about 2.5 million light years away and counting around 100 trillion stars, making it a larger known galaxy in our local group. The night sky with its wide band of stars represents only a small part of our galaxy. Beyond the gas clouds in space, this band is not just strips of clouds. It is a group of stars formed by the fusion of countless stars, appearing less bright and distinct from Earth. However, our universe contains not only billions of galaxies. Andromeda galaxy with IC 1101 known galaxies is the larger galaxy in our known universe, situated 1.045 billion light years away from the Earth. In this video, we covered just a fraction of the vastness of complexity of our universe. Stay tuned for more informative video, and until then, goodbye.